Okay, here I have an improper integral because of that limit of integration there. I have to evaluate it. So when I look at an integral like this that I have to evaluate on a non-calc section, you either know the antiderivative, or if you don't, there's a technique you might use. I think I can do a u substitution because I see an x cubed and I see an x squared above, which is its derivative, or a version of its derivative. So let's change this problem. First, I'm going to use good notation in this explanation. Okay, let's just say I'm going to replace this with an a, make it a definite integral. Okay, so let's deal with this, and then we'll push a off to infinity. So here I'm gonna let u be that denominator, so that du can be written like that, and then I note that x squared dx can be replaced with du over du over 3. And the only thing left to do is to note my limits of integration. So, okay, when x is equal to 1, according to this relationship, u is equal to 3. And when x is equal to a, u is equal to a cubed plus 2. So now my integral can become, okay, the integral from, so it's 3 to a cubed plus 2. X squared dx became a du over 3. And then the denominator, right, this is now what I'm calling u. So that's u squared. All right, and so still work to do. Let's think of this as u to the negative 2 for its antiderivative. So add 1 to the exponent, gives you negative 1. So I think this is what we want, right? Okay, evaluated from 3 to a cubed plus 2. Okay, so I might, again, I think this is, I'm going to rewrite this as negative 1 over 3u. So that's negative 1 over 3 times the quantity a cubed plus 2 minus fundamental theorem minus, and then negative 1 over 3 times 3. And then don't forget that we're taking, we're taking a going off to infinity now. So as a goes to infinity, this expression here is going to vanish, right? Because you've got the denominator getting arbitrarily large. So I'm left with 1/9. So 1/9, which is B.